Today, when it comes to the benefits of cloud computing, right, everybody is very familiar. That does not need to be explained anymore. Everybody knows about it. But when it comes to the semiconductor industry, there is still some hesitation in moving data to cloud, especially your important IP data. People just have, what is it? What are those hesitations? Why is this the case? Let's look at a few things, right? Migration complexity. So seamless migration of data into cloud, if you think about it with zero downtime, it's a complex task. That's the first thing. It's the first level of hesitation. Then you have a large team of engineers spread out in different geographies, and they're working on important projects that never seems to have any time for downtime, right? So that's your second problem there. And when people are using manual methods to move data from on-premise to cloud, there's again a high risk, right? There could be data inconsistencies, and it'll lead to costly errors you don't want. So you have extra data validation steps and all of that. So what is really needed here? We're looking for a near zero downtime method to move data over, and we also want something that is risk-free. So how do we do this? Right? So before I step into the solution, I'm going to talk about the traditional method that's used for doing data repository migration to cloud, right? So I have three steps in here, T1, T2, and T3. And the first step is quite simple. You set up cloud infrastructure. Second step, you sync the data to the cloud. Remember, you're using manual methods here, so this will, depending on the data size, you're going to have that much downtime for the users. And lastly, you start up the cloud repository, and then you have to reconfigure all the user workflows and their work areas to point to the new location. And you also have to shut off the first the data repository that was in the original location to make sure nobody accidentally writes into that and things like that. So there's all of this that needs to be done, right? It's not simple. So what do we have here? With Keysight Design Data Management, SOS, we have a new repository replication methodology, and we have, I'm going to explain this as R1, R2, and R3. And these steps are also very simple, and you'll see how they're immediately giving you some benefits. So first step is the same. You still have to set up the repository, so you have to set up a replication service on the cloud. But before that, you need to set up a cloud instance for doing that, right? So that's where AWS comes in, and he will explain in the next slide how that's going to be done. The second step is to sync the data to the cloud via the replication service that we create on the cloud. And I'm going to explain that a little bit later. The last step is to simply promote that replication service on the cloud, and it automatically takes care of reconfiguring the caches and the work areas and everything to point to the new location, shuts off the old primary server, and all is good to go. So let me bring up this architecture diagram here. So on the left, you have the on-premise. You have the physical server machines there where you've set up the primary repository. That's the original primary repository. And on the right side, you have the AWS cloud setting. And now I'm going to hand it over to Felix here to explain this portion of it.
So we'll talk about the AWS cloud infrastructure over here, right? So a couple of key concepts that I wanted to highlight over here. So the first is the VPC, right? So VPC stands for Virtual Private Cloud, and this is a isolated section of the AWS cloud wherein you could launch resources into your virtual network. And VPCs are further subdivided into subnets. So if you have two kinds of subnets, a public subnet and a private subnet. A public subnet is a network segment wherein you host public facing internet resources. And a private subnet is where you have internal only secure resources, right? And this is where we deploy the EC2 instance. This is going to be the replication server on which we deploy the replication service. And what this has is an EBS volume which will host the replication repository. EBS stands for Elastic Block Store, and this offers persistent block level storage for your EC2 instances. So really, as you can see, configuring a replication service on AWS cloud is really easy, and to make it automated, right? We have the concept of infrastructure as code, wherein you can use a tool such as CloudFormation or Terraform to develop, deploy, and manage this infrastructure on AWS, right? So obviously the benefits include version control, consistency, and a way to basically deploy this infrastructure in a repeatable manner across different accounts, right, and different regions. So for example, you could have a Terraform template that will deploy all of this in a non-production environment and then easily do the same deployment in a production environment, right? And this doesn't have to be manual. This can be in Terraform, and again, you can have version control on top of that. A couple of other key concepts I wanted to touch upon. First is when it comes to cost control, right? So on AWS, we have services such as Cost Explorer, which will give you fine-grained visibility into your costs. And also you have various cost optimization strategies such as reserved instances, savings plans, spot instances. You can also employ techniques such as EC2 instance, right sizing, auto scaling. All of these methods are available when it comes to cost management on AWS. And then lastly, when it comes to security, right? Security is a big piece. We always say security is job zero at AWS. So there's a comprehensive security model which is based on the shared responsibility principle, where AWS is responsible for security of the cloud. This is the infrastructure, and customers are responsible for security in the cloud, right? So this includes your data access control, encryption, right? And we usually employ a layered approach for security. So when it comes to user access, we employ a service such as identity and access control, IAM. And then when it comes to network security, we have security groups and network access control lists. And for encryption, we use a service such as key management service, wherein you can create your keys and encrypt your data. And then lastly, when it comes to your security audit logging, right? We have services such as CloudTrail, which will provide comprehensive security audit logging capabilities. So really, we talked about how easy, secure, and cost-effective it is to deploy a replication service on AWS. With this, I'll hand it back to Pratna.
So he talked about how to set up things on cloud, how simple it is, how secure it is, and all the other features there are, right? So that part is covered. So now you can see the on-premise, the original primary service over there. So this is R1, the setup is done here. And then R2 is the step where the asynchronous replication takes place from the primary service to the cloud to move the data over. And then R3 is simply to promote the new replicated service as the new primary. And now I'm just going to go over the steps. So this will actually explain the previous diagram a little bit better. So on the left side, I have the primary site with the repository, a local cache, which the users are pointing to. The local cache is synced with the repository. And on the right side, I have the remote site, which is on the cloud, in this case, AWS cloud. And we are adding and starting up a new replication service there. Step 2 is to make sure that the asynchronous replication of data and metadata from the primary site to the replica service is done. Once it's so when I say asynchronous, and that's the key term here, because nobody is waiting on this this is no downtime practically. This is just happening in the background. That's the biggest advantage here. So once the syncing completes, now you'll see that the caches, what used to be the local cache is now the remote cache. What used to be the remote cache is now the local cache. And the users are pointing to exactly where they should be pointing without doing any configuration changes at all. This is all taken care of by SOS, Keysight SOS, right? So once the syncing takes place, it's completed, we made sure it's complete, then there is a manual step of simply promoting the replica to become the primary. And then as a fourth step, you can demote the old primary and delete it. This step is optional. You don't have to. It's more like if there is an event, a disaster that has happened, the whole site is down, you have a standby site that you can bring up in very near zero time, I would like to say that. And when the disaster is done, or when the server issues have been fixed, you can always go back. You can again demote this one, you can promote the old one and come back again. Or if this was simply a way to move data over to the cloud, then you've successfully done that as well. And now these are just some screenshots that show you how simple it is. You simply add the local replica and you start it up, check the logs to make sure that the syncing is completed. You promote the replica to become the new primary, and as an optional step, you can delete the old primary. And here's the data from our experiments. I mean, what we ran with 3 different sets of data. We had a small digital chip with 1 gigabyte, and then we used a small PMIC, which was data was about 10 gigabytes, and then we had the large SoC with 100 gigabytes. And you can see the comparison of T1, T2, T3 steps, and R1, R2, and R3. You'll see that the setup of cloud infrastructure is very quick, right? It's all there. It's because AWS provides these instances that are pre-configured for the purpose of EDA workloads. So it's all taken care of there. And then syncing of data to cloud, you can see how much time it takes, right? So here's what we're really worried about. 1 hour, 26 minutes, and you compare it to R2, you have it's taking about 1 hour and 14 minutes, which is fine. That's not the important part. The important part is that there is no downtime because it's an asynchronous replication, right? And then the last step here is in T3, they're just starting up the server and they have to reconfigure. The reconfiguring actually takes more time, which I haven't accounted for here. But assuming it's just, starting up of the server, that only takes like a few seconds. And R3 here, again, it's just the promotion step alone. So this is the only step where users actually experience downtime with the new replication methodology. So if you actually want to look at the time savings, you compare R3 minus R2, T2 minus R3. This is more difficult when you say it. And you end up with 99% savings. And it looks like a lot, but you just have to understand that the asynchronous syncing is the key here. Now, how does this help with the initial fears that I was talking about, the hesitation, the semiconductor industry? Why do they not want to hesitate? Why do they hesitate to move to cloud, right? So we talked about the downtimes. The new method takes care of that. We also talked about the need for extra data validation because of high risks with manual moving of data. This takes care of both of them at the same time because there's automation built in to make sure only one of the services is running at any given time to avoid unnecessary writing into the old repository. And then there's also inbuilt database integrity, ensuring that the data is exactly the same as what it was in the old primary. So you don't have to do any extra validation steps to make sure it's the same data. The database has those checks built in. So with this new repository replication methodology, we hope that more companies are open to moving their data to cloud. And you can consider AWS for that because we partner with them, and we also partner with other cloud vendors as well, but it's all taken care of with this new methodology. So I hope you guys learned something, and if you have any questions at all, please feel free to ask me.